Now, in previous lecture, we are discussing about steam turbine, impulse turbine, reaction turbine, and we have discussed difference between impulse turbine and reaction turbine, working on impulse and reaction turbine. Now, today we have discussed why compounding is required. The steam produced in the boiler has got very high enthalpy. In all turbine blades, velocity is directly proportional to the velocity of steam passing over the blades. Why compounding is required? See, what happened actually due to high velocity of the steam, our impulse turbine blades rotate up to very high velocity, up to means 30,000 rpm near about. So this is very high speed. This speed is not possible in practical condition. So for controlling this speed, we are required compounding. Means controlling this speed, we are for this controlling process, we have called compounding. Means simply compounding means control the speed of the rotor of the turbine. Okay, got it? So steam produced in the boiler has got very high enthalpy. In all turbines, the blade velocity is directly proportional to velocity of steam passing over the blade. Now, if the entire energy of the steam is extracted in one stage, that is, if the steam is expanded from the boiler pressure to the condenser pressure in a single stage, then its velocity will be very high, hence the velocity of rotor to which the blade is geared can reach about 30,000 rpm, which is pretty high for practical uses. Means this high speed we have not used for practical, not possible in practical. So we have control this speed. We are required to controlling this speed. This process is called compounding. So moreover, at such high speed and centrifugal force are immense, which can damage the structure, hence compounding is needed. Well, see here, moreover, at such high speed, the centrifugal forces are immense, which can damage structure, hence compounding is needed. Types of compounded impulse turbine: pressure compounded impulse turbine, velocity compounded impulse turbine, pressure and velocity compounded impulse turbine. What is compounding? Compounding is employed for reducing the rotational speed of the impulse turbine to practical limits. Compounding of steam turbine is the method in which energy from the steam is extracted in the number of stages rather than single stage in the turbine. A compounded steam turbine has multiple stages. It has more than one set of nozzle and rotor in series geared to the shaft or fixed to the casing so that entire steam pressure or the jet velocity is absorbed by the turbine in number of stages. See here, what is compounding? Compounding is employed for reducing the rotational speed or controlling the rotational speed of the impulse turbine to practical limits. The compounding of steam turbine is the method in which energy from the steam is extracted in number of stages rather than single stage in the turbine. A compound steam turbine has multiple stages. It has more than one set of nozzle and rotor in series create to the shaft or fixed create to the shaft or fixed to the casing so that either the steam pressure or the jet velocity is absorbed by the turbine in number of stages. Okay, means compound is simply to control the speed of the our turbine rotor. So types of compounding: pressure compounding, velocity compounding, pressure and velocity compounding. All methods used for controlling the speed of the rotor. Now, in that here, pressure compounding, in this type of turbine, the compounding is done for pressure of steam only, that is to reduce the high rotational speed. Of the turbine, the whole expansion of the steam is arranged in number of steps by employing a number of simple turbines in a series created on the same shaft. Each of these simple impulse turbines consisting of one set of nozzle and row of moving blade is known as stage of the turbine, and thus this turbine consists of several stages. The exhaust from each row of moving blade enter the succeeding set of nozzles. Now, thus, we can say that this arrangement is nothing but splitting up whole pressure drop from the steam chest pressure to the condenser pressure into a series of small pressure drop across several stages of impulse turbine, and hence turbine is called pressure compounded impulse turbine. This is also known as Retnov turbine. Retnov turbine. See, in this figure, we have seen here diagrammatic arrangement of pressure compounding impulse turbine. See, here at the starting of this turbine, very high pressure means steam coming from boiler to the nozzle. At the nozzle, our velocity is low and boiler pressure is very high. In nozzle, this situation at the inlet of nozzle, after steam passing through nozzle, in nozzle, our pressure drop and velocity increase. Pressure drop and velocity increase. After that, moving blade there. So in moving blade, pressure is constant, velocity decrease. In nozzle, velocity increase, pressure decrease. Moving blade, velocity decrease, pressure constant. Like that same process continue. So in this way, at the last, we have controlled this high pressure and speed of the turbine like that. This is number of stages like that. This is one stage, this is second. This diagram shows pressure compounding for impulse turbine. Same we have seen in previous diagram. In the nozzle, our pressure energy drop and kinetic energy increase. In moving blade, kinetic energy decrease, pressure constant. Also, nozzle increase kinetic energy, pressure drop. Moving blade decrease kinetic energy, pressure constant, like that. In this way, continuously, we have controlled all parameters. In this way, we have controlled all parameters हॅलो हां सर तिथं सिक्युरिटीकडे असेल तुम्ही घेऊन घ्या मी लेक्चरमध्ये मी बोलतो नंतर हो 1 minute. See here in this diagram, same pressure increase, solid pressure decrease in nozzle and kinetic energy increase. In this way, we have control pressure, velocity, and speed of the turbine. So pressure compounded turbine, here pressure compounded means controlling the pressure and speed of the turbine, that is called pressure compounded. Now, in previous types of compounding, pressure compounding, we have controlled pressure. Now, we have controlled velocity. Here, we have controlled pressure. Now, we have controlled velocity. So, this is called velocity compounding. In this type of turbine, the compounding is done for the velocity of steam only. That is, drop in velocity is arranged in many small drops through many moving row of blade instead of single row of moving blade. In this turbine, moving and fixed blade are pressed alternately. Moving blades are fitted with the wheel while the fixed blade are fitted with the casing. The whole expansion of steam from the steam chest pressure down to the exhaust pressure takes place in the nozzle only. Therefore, pressure remains constant after nozzle. It is also known as Curtis turbine. See, in this velocity compounding diagram or diagrammatic arrangement of velocity compounding impulse turbine, see here, steam pressure and steam velocity like that enter the nozzle, our pressure suddenly drop and velocity increase in nozzle. After that, this steam passes over moving blade, our our velocity decrease and pressure increase. Velocity decrease and pressure is constant throughout. After that, guided function of guided blade to guide the steam, flow of steam. Here, velocity is constant, pressure also constant. Against moving blade, in the moving blade, kinetic energy decrease or velocity decrease and pressure constant. Against guided blade, both pressure and velocity is constant. In moving blade, kinetic energy decrease means velocity decrease, like that. So see here, continuously controlling the velocity of the turbine means using velocity controlling, we have controlled here speed of the rotor. Simple. We can see here. At the start, velocity is very low, but steam going through the nozzle, our steam velocity suddenly increase. Now control this is suddenly increase velocity by moving blade, but guide vanes in the steam velocity in guide vanes is constant. Against we have used moving blade, so control the velocity continuously in number of pages. We have controlled this high velocity of the turbine. This is velocity compounding or Curtis stage of impulse turbine. Now this is diagram, clear diagram for the velocity compounding. See here, pressure of steam at inlet, initial velocity at the inlet pressure is very high and velocity is very low of the steam, but steam passes through the nozzle, our steam pressure suddenly increase steam velocity and steam pressure suddenly decrease. After that, steam passing through moving blades, in here our velocity slightly decrease and pressure constant. After that, stationary blade or guided blade, here both parameters are constants of the steam. After that, against use moving blade, in this moving blade, our velocity decrease, pressure constant. This is continuous process, number of stages. Here, this is principle of velocity compounding in impulse turbine. So velocity compounding turbine, here after decreasing pressure constant throughout and velocity continuously decreases. That's why we are saying this is velocity controlled by velocity we have controlled speed of the rotor. So this is velocity compounded turbine. Now next compounding method, pressure velocity compounding. Next compounding method, pressure velocity compounding. Here we consider pressure and velocity simultaneously. Hence it is named as pressure velocity compounded impulse turbine. Here we have arranged of two rotors or wheels. In each rotor we have installed of many row of moving blade. Hence we get decrease in velocity. Also, we install two nozzles in hole arrangement which help in splitting pressure. Here we use two rows wheel as we consider two row wheels arrangement more efficient than three row wheel arrangement. We can see here pressure velocity compounding in previous two pressure. In previous two cases, we have discussed pressure compounding, velocity compounding. In pressure compounding, we have controlled turbine speed by using pressure, controlling the pressure. In velocity compounding, we have controlled velocity. Sorry, we have controlled steam turbine speed by controlling the velocity. Now, both combine pressure velocity compounding using controlling the pressure and velocity both here. So, see here at the starting, our pressure is high and inlet velocity is very low before at the inlet of the nozzle. After steam passing through nozzle, our velocity increase and pressure decrease. After that, steam passes over the moving blade. In moving blade, pressure decrease and velocity decrease and pressure constant. After that, steam passes over the guided bed. In guided bed, both parameters are constant of the steam. Also, we have used moving bed. In moving bed, kinetic energy or velocity decrease and pressure constant. See, after that, once again, we have used nozzle. In nozzle, kinetic energy increase, in nozzle, kinetic energy increase. After that, steam passes over moving bed. After that, steam passes over guided bed. Once again, moving bed, and we have controlled the velocity of the steam and pressure of the steam. Before here, to main here, in this nozzle, velocity increase, pressure drop here. Also here, velocity increase and pressure once again drop, means control pressure and velocity both here. This is diagrammatic arrangement of pressure velocity compounded of impulse turbine. Now, this is diagram. See here, at the inlet of the nozzle, velocity is very low, but after steam passing through nozzle, our velocity increase and pressure decrease. In moving bed, velocity decrease, pressure constant. Guided bed, both parameter constant. In moving bed, velocity decrease, pressure constant. After that, once again use nozzles. In nozzles, velocity increase and pressure decrease. Same process repeat. In moving bed, kinetic energy decrease and this pressure is constant. After that, moving bed, kinetic energy decrease and this pressure constant. Right there. See here, pressure velocity compounding. See, in the nozzle, pressure decrease, velocity increase. For our understanding, please remember these things. In nozzle, steam passes through nozzle, pressure decrease and velocity increase. In moving bed, our pressure constant but velocity is decreased. In fixed bed, velocity constant, pressure constant, velocity constant. In moving bed, pressure constant, velocity decrease. Like that. Steam turbine blade technology. So this is not in syllabus, but for our knowledge, we have seen this part, steam technology, turbine blade terminology. So see here, flow direction, arc-wise directions, leading edge, this is leading edge, suction side, span-wise direction, hub, trailing edge, pressure side, blade tip, arc-wise direction, and this is flow direction. Here we have covered total compounding of the steam turbine. Here, any doubt, any queries, please ask me. After that, we have discussed velocity triangles and derivation for steam turbine. So any doubt, any queries, please ask me. Any doubt, any queries, please ask me. In compounding, pressure compounding, velocity compounding, pressure velocity compounding, any doubt, any queries, please ask me. So now we have start here velocity triangles. So the three velocity the three velocity vector, namely blade speed, absolute velocity, and relative velocity. Blade speed, absolute velocity, and relative velocity. In the relation to the rotor are used to form a triangle called velocity triangle. So velocity triangle are used to instructed the flow in the blading of turbo machinery. Changes in the flow direction and velocity are easy to understand. With the help of velocity triangle, note that the velocity triangle are drawn for the inlet and outlet of the rotor at certain radii. Velocity triangle are used to instruct the flow in the blading of turbo machinery. Changes in the flow direction and velocity are easy to understand. With the help of velocity triangle, note that the velocity triangle are drawn from the inlet and outlet of the rotor at certain radii, like that. See here, since this is inlet velocity triangle, this is inlet absolute velocity, this is blade speed at inlet, this is wheel velocity, this is relative velocity at inlet, this is flow velocity at outlet or axial velocity. Now see here, this is outlet velocity triangle. VW2 is outlet velocity at wheel, U is outlet velocity of blade speed, VW2 is the relative velocity at outlet, V2 is the absolute velocity at outlet, and V2 is the axial velocity at outlet. Now see a combined velocity diagram triangle, because here blade speed is same. Because here blade speed is same. So we have combined this diagram, inlet and outlet triangle. So after combination of this diagram, we are getting like that. This is your inlet triangle. This is your outlet triangle. See, this is VW1, V1, VA1. We know all things. Only common this blade velocity. In this diagram, we have see steam impacting on the impulse turbine blade, moving blade. Now, analysis of single phase turbine. General velocity diagram of impulse turbine. If there is no frictional loss, then the axial thrust is zero as Vf1 equal to Vf2 and Vr1 equal to Vr2. If there is no friction loss, then the axial thrust is zero. That's why Vf1 equal to Vf2 and Vr1 equal to Vr2. In this diagram, we have seen or analyzed single phase turbine. So this article is very big. So this article we will conduct or we will take in next lecture. So today we have stopped here because time is very short. So all of you, any doubt, any queries, you have asked me. Any doubt, any queries, please ask me. All of you, unmute. Unmute, all of you. Simran, Prasad, Nikita, Kunal. Any doubt, any queries, please ask me. Prasad.
No, sir, no doubts.
No, sir. No, sir.
So today we have stopped here. In next lecture, we have completed theory part of this fourth unit, only derivation remaining. After that, we have continue on problem on steam turbine. Okay. Hello. Nikita. Hello.
Yes, sir.
All of you there?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
Yes, sir.
in next lecture, continue told your friends to attend this lecture, online lecture, because this is fourth unit covered in next up to Monday or Tuesday. Completed this fourth unit. So please attend this lecture. I also upload YouTube videos
बघा बघा
on Google Classroom. So
हा याच्यामध्ये विदाउट ऑइलची वगैरे होईल शिजून वगैरे होईल छान
hello. Any doubt, any queries, please ask. Okay. Thank you.